Good morning, children. Today we are going to study activity 3 based upon temperature and kinetic energy. In previous class, we have studied about thermal equilibrium, and based upon the thermal equilibrium, we have studied activity 2. Let me recapitulate that particular what is meant by thermal equilibrium. Heat lost by a body is equal to heat gained by a body. Based upon that particular principle, when two bodies of different temperature, if you are making in contact with each other, the temperature heat transmission can be taken place from hot body to cold body, and cold body gains heat from hot body, so that both bodies attain one certain constant temperature, that is called as thermal equilibrium. Based upon that, we have completed activity in previous class. Today, we are going to frame an activity based upon one concept called as temperature and kinetic energy. What is meant by temperature? It is a measure of degree of hotness as well as coldness of a body. To measure the temperature of body, whether the body is hot or cool, it can be measured by using a device called as thermometer, on which scale will be get mentioned, such as Celsius scale, Fahrenheit scale or Kelvin scale. By using a device called as thermometer, we can measure temperature. That is regarding temperature. Coming to our next one is kinetic energy. What is called as kinetic energy? Kinetic energy is nothing but what? It is an energy of a body or a molecule, as we are discussing about molecules. Kinetic energy of molecules. It is the energy of body or a molecule that it possesses due to virtue of its motion. By its motion, a body if it is in motion, a molecule if it is in motion, depending upon that motion, what else the energy is possessed by a body, it is called as nothing but what? Kinetic energy. Now coming to kinetic energy formula, kinetic energy is equal to half mv square. In work energy topic we have studied there itself. Kinetic energy is nothing but what? Half mv square. Where m indicates mass of the body, v indicates velocity of the body. Kinetic energy is directly proportional to mass of the body as well as square of its velocity. We can give it up, that is nothing but what? Kinetic energy. As we are going with the energy of a body, examples that we did. Moving car, a car which is moving on the road, it possesses kinetic energy. Similarly, a bullet from the gun, as a policeman or a militaryman, if he fires the bullet which will travel with high velocity there itself. By the virtue of kinetic energy only, the bullet is traveling from one point to another point. We can do it. Running or walking of a person, early in the morning, our parents, what they will do, they will go for walk. That walking indicates nothing but what? It is for the sake of their health they are walking there, because it nothing but what? They are performing one energy. The body is in motion there itself. Running, if you go for athlete, 100 meter run, 200 meter run, or else 800 meter run, if you go there, we'll sit up as the person who is giving indication. When he fires the bullet, what happens? The running starts there itself. Who wants first, who will complete the race within the seconds, he will be the winner of that run. There also the bodies are possessing what energy? Kinetic energy. Similarly, one more example, let me give it up. While playing cricket or while playing football, to hit the goal, the person what he will do, he will roll the ball. Controlling of ball in the ground is also nothing but what? That ball also possesses kinetic energy. Hitting by a person there itself. A player is hitting the ball into the goal. It also nothing but what? Possessing kinetic energy. Flying aeroplane is also nothing but what? I will possess a certain energy. That energy is called as kinetic energy. These are some examples of what? Energy of a body. Coming to kinetic energy of a molecule. Next one is what? Kinetic. Now coming to kinetic energy of molecules. Molecules can be of body consisting of solid, liquid as well as gases. When these, as we are dealing with the concept called as temperature and kinetic energy of the molecules. Temperature, how it is relating to kinetic energy of the molecule. For example, if you take any substance, any molecule substance, either solid, liquid or gases. If you have taken three substances there itself, and if you have present temperature increasing, when the substance is increasing its temperature, what happened? Heat will be added to the particular substances. Heat will be added to the particular substances which are existing in solid, liquid as well as gaseous state. How that particular heat is added when temperature is added to this particular molecule. If you go for solid substances are nothing but what? Very closely packed to each other. When it comes to liquid substances are what? Which are very loosely packed to each other. When it comes to gaseous particles, gas molecules, they are freely packed to each other. So that depending upon their arrangement of molecules in solid, liquid as well as gases, when the temperature is increases, heat will be gained by solid substances, liquid substances as well as gaseous substances or molecules. How that heat will be gained? If you go for solids, the kinetic energy of solids will be very low. Very low observation will be taking place. Why? The intermolecule structure of the particular solid is much more closer. As it is closer, within that fixed location itself only, within this fixed locations only, the particles vibrates, the molecules vibrates very low. Due to that reason, it attains less energy. Less temperature, less heat can be absorbed. When it comes to liquids are what? Loosely packed to one another. So what happened as temperature is increasing to this particular liquids? What happened? These liquids, as they are in loosely packed nature, they can slide one over the other. They can slide one over the other. We know that liquids take the shape of container. In which container we are adding liquid, it will attain that shape. As it is in a loosely moving motion, slide one another, it can be taken place. Randomly they can overcome one another. Due to that reason, little bit more energy, little bit more heat can be absorbed by liquids than that of solids. Coming to gases molecules are very freely packed to each other, so that what happened, randomly they can move, they can slide one over the other, as well as they can also combine in the form of a straight line. Due to that reason, high heat will be get absorbed within this particular gases. That is the reason among all, if you go it up, kinetic energy of molecule based upon temperature. Based upon temperature, if you do it up, as temperature is increasing, kinetic energy in gases will be much more, heat will be absorbed much more in gases than that of liquids, than that of solids. Why? The arrangement of molecules. The molecules in solids are closely packed to each other. Due to this, the particle vibrates in its own position only, with very little bit of heat will be get absorbed. With liquids, molecules slide one over the other, randomly they will be get moving it up. So that due to that reason, little bit more temperature heat can be observed than that of solids. Coming to gases, as they are freely packed to one another, freely packed, they can move randomly, they can also come in a straight line also. As temperature is observed, heat is observed. So, more quantity of heat can be observed within this particular solid substances. Gaseous substances. Therefore, kinetic energy of molecules based upon temperature, if you do it in gases, it will be more energy can be observed than that of liquids, than that of solids. This concept you can study much more clearly in kinetic theory of kinetic energy of molecules. We can study much more clearly this particular concept in kinetic molecular theory in higher classes. Now coming to activity. How this particular activity we can perform. Okay children, now coming to activity 3 based upon temperature and kinetic energy. Already we have studied clearly that when any substance, whether it is solid, liquid or gases, if we are increasing temperature to that particular substance, kinetic energy is added to that particular substance, we have studied clearly. That kinetic energy, what else we are adding to the substance, will be greater in gases than liquids, than solids. Now we are taking an example based upon temperature and kinetic energy gaining. Kinetic energy gaining by gaining what? Heat. How it is gaining within this activity 3 we will discuss. We have taken two substances, same substances, that is nothing but what? Water we have taken. Equal in quantity I have taken 2 beakers. Within these 2 beakers, equal in quantity I have taken water. But in one beaker I have taken cold water, in another beaker I have taken hot water. Of equal quantity, in other beaker water temperature is a little bit high. Then afterwards what happened? At same time interval, I am adding certain ingredients of colors. Means what? Sprinkling of what? Food color to those 2 waters. One is cold water, other one is hot water. Then what we can observe is how this particular food color mix up with that particular water molecule. Let me see it. Coming to the first question here, we will get arrangement, we will get an idea, we will get a question in our mind. How do they move? That color when you are adding to this particular liquids, how that particular color can be get moved? They move as they are liquids. What we taken there? Liquids. Liquids will have gain of heat energy of the molecules greater than that of solids. Therefore, they move randomly. Randomly means what? They will come slide to one another, upward direction, in all directions they will move randomly. Simultaneously slide one over the other, so that what happened, the movement of that particular substance of liquid water will be randomly, they will move it up. Why do they move? They move because they are liquids. When it comes to solids, the molecules are closely packed to one another. Intermolecular particles will vibrate around its own fixed region. They cannot move randomly. But whereas in liquid, they can move. Therefore, as they are liquids, in liquids, molecules can move in all directions and they can slide one over the other. Next question is what? Why do grains in hot water, as we observed clearly this one, we'll observe that the grains which are existing, the color grains which are existing in hot water will move much more randomly, much more fastly. They will be mixing up with the water compared to that of cold water. Why it is taking place that one? Means what? Why it is taking place? First thing is what? We have to understand one point. These 2 bodies are nothing but attaining kinetic energy. They are possessing kinetic energy. The kinetic energy means what? By the virtue of its motion of the particles. Here temperature is what? Room temperature only. But whereas here it what? Temperature is greater than that of room temperature here. As the temperature is greater than that of room temperature, kinetic energy temperature increases means what happens there itself? Adding of heat to the kinetic energy of the molecules also will be gradually increases. Due to that reason, what happens? Two bodies are possessing kinetic energy, but if you compare the mixing of the particular molecule, speed of the molecule, as it is at room temperature, here kinetic energy will be less, and as it is at a greater than room temperature, kinetic energy will be little bit high. Depending upon that high temperature, they possess more kinetic energy, they possess less kinetic energy. Therefore, different in kinetic energy, we are getting it or not? As they are of same material only, but one is at room temperature, other one is at what? Little bit more temperature we have added. Means what? As temperature increases, what happened? Kinetic energy within that particular molecule also gradually increases as they are different. Not only that, but due to that reason, if you consider average kinetic energy of hot body and average kinetic energy of cold body, if you compare together, we will get difference. We can clearly give an answer that hot body possesses more average kinetic energy compared to that of cold water body. Due to that difference in temperature, that difference in temperature can be measured by what? The difference in temperature is nothing but what? Indicator of average kinetic energy. Hot body is possessing high kinetic energy. How we are identifying? Depending upon temperature. Cold body is possessing lowest average kinetic energy than that of hot body. Why? Depending upon temperature. In cold body, less temperature is there. In hot body, high temperature is there. Therefore, temperature is playing a major role. It is acting like an indicator. It is an indicator to measure whether which same liquid only, one is at cold temperature, other one is at hot temperature, hot water and cold water. The variation in these things can be easily identified by temperature. Therefore, we can frame one formula. What is that formula? Is average kinetic energy of molecules. Average kinetic energy of molecules, whether it is solid, liquid, gases, it is directly proportional to temperature. That too of what temperature? Absolute temperature. If you see term of same material within liquids, cold water and hot water, depending upon cold water, kinetic energy of the molecules, the temperature gained by cold water molecules is directly proportional to temperature there. Similarly, coming to hot water, the average kinetic energy of the molecules, as temperature is high, heat gained by the molecules will also be a little bit high compared to that of that one, that is directly proportional to the temperature. Therefore, by this we understood that kinetic temperature and kinetic energy, we got a relation that is nothing but what? Kinetic energy is directly proportional to absolute temperature. Average kinetic energy of the molecules is directly proportional to temperature. By this we have completed this activity. Within this activity we have taken same material themselves. Same water, same liquid, water, but one is at different temperature, other one is at different temperature. So that what happened if different, same material, same liquid substance but different temperature, temperature is playing vital role in average motion of what? Kinetic energy of the molecule. So children, based upon this class, just try to understand the concept and try to see the concept much more times so that you can get clarity regarding the topic. And in next class, we will go to the same topic, temperature and kinetic energy in activity 4, in which different materials will take it up. In liquids only, one is of water, other one is of some other material. If you take it up, how that particular temperature variation, average kinetic energy of temperature depends upon average kinetic energy of molecules, how it depends upon kinetic energy. Thank you, children.